Welcome to the Deep Dive, your shortcut to mastering complex topics fast.
Ah,
Today, we're tackling probably the biggest headache in AI development right now, connection chaos.
yeah, we're talking about that critical moment when a large language model, which is, fundamentally a static brain trained on text, needs to actually interact with the real world.
Your databases, Slack, GitHub, maybe even just local files in your machine.
Exactly. And until, late 2024, doing that was, well, it was a complete mess.
Right, it was custom work every single time. People started calling it the NXM integration problem.
Yeah.
You've got N different AI models, M different tools or data sources.
And connecting any pair meant writing specific, often brittle glue code. It was just hugely inefficient.
Totally unscalable. And it really slowed down progress on making AI agents genuinely useful, didn't it?
Oh, absolutely. A major architectural bottleneck. And the
Mm.
first attempts to solve it were proprietary, which honestly just made the fragmentation worse. You were locked into one vendor system.
But the sources we've been looking at, tracking things since that big shift around November 25th, 2024, show the industry seems to have finally landed on a consensus.
Which brings us to the Model Context Protocol, or MCP.
Yep, MCP. It's open source and open standard, kicked off by Anthropic, but crucially, jumped on very quickly by the big players OpenAI, Google DeepMind.
And the goal here is a universal bidirectional interface. It's the plumbing, really, that lets an LLM reach beyond its initial training data.
To build those useful, goal-driven AI agents everyone's been talking about.
Precisely.
Okay, let's unpack this. This is being called the USB-C for AI. And we're going to dive into how it impacts competition, gets us past that fragmentation mess, and crucially, how it lets AI start doing things for you safely.
That USB-C analogy is actually quite powerful when you think about the strategy behind it.
Because the NXM problem wasn't just a tech headache, it was also kind of a business strategy, right? A way to lock developers in.
Exactly. If you invested time building a tool using, say, OpenAI's specific function calling setup, that tool was stuck there.
Want to use it with Anthropic's Claude or Google's Gemini? Tough luck. Start over.
Pretty much. It created these walled gardens, these vertically integrated silos where the platform owner controlled the connections.
Okay, so if MCP standardizes that connection layer, makes the glue generic, why did the big companies agree? Why give up that control?
Well, that seems to be the core strategic bet here. The sources suggest the fragmentation was actually slowing down the whole market for agentic AI. Everyone was struggling with the same integration problems.
Ah, so by standardizing the protocol, they're saying, let's compete on how good our actual models are, not on who has the stickiest connectors.
Exactly. It's an accelerator. It dramatically lowers the barrier for anyone wanting to build a tool. More tools, better tools get built faster.
Which drives demand for the best underlying AI brain, whoever makes it.
Right. They're betting an open standard grows the whole pie much faster than proprietary lock-in could. Makes sense.
It does. And for developers, the win is obvious.
Oh, huge. You build your MCP server once, say, for connecting to Salesforce or a specific database, and it should just work with any MCP compliant host, any compliant LLM.
No more writing the same connection logic over and over. The DRY principle, don't repeat yourself, finally applied here.
Yep, cuts out tons of that boilerplate code.
And for you, the listener, the payoff is potentially a big step up in what AI can do for you.
Absolutely. This enables a new class of AI assistants, ones that can, with your permission, securely access your personal stuff, Google Calendar, Notion, local files, whatever.
And not just read it, but actually perform complex actions based on it.
Turning them from just chatbots into, well, real productivity partners.
Okay, that's the perfect transition to security. Because letting an AI into my calendar or my files, that requires a lot of trust. How does MCP handle security and consent?
So the architecture itself is client-server. It took a lot of inspiration from the language server protocol, LSP.
LSP.
Yeah.
That's the thing that lets different code editors, like VS Code or whatever, talk to different language compilers,
Yeah.
right?
Exactly that. LSP standardized the editor-to-compiler communication. MCP aims to do the same for LLMs talking to external tools and data.
Okay, so you mentioned three parts: host, client, and server. The host is the main application I'm using, like the chat window or the IDE.
Yes, precisely. The host is your primary interface. And critically, the host is the only component responsible for enforcing security policies and getting user consent.
The only one.
The only one. The host ensures that the GitHub server learns absolutely nothing about the HR data. It doesn't even know the HR server exists in the same session.
So the tools are isolated from each other. Like they're in separate soundproof rooms, and only the host can talk to both.
That's a great way to put it. The host mediates everything.
Okay, that makes sense architecturally. And the client and server rules. Quickly.
Sure, the client lives inside the host. Its job is to translate the LLM's intention, like, I need to send a Slack message, into a formal request for the server. It uses a standard format called JSON RPC.
JSON RPC. Just a structured message format.
Yeah, basically using JSON, which is super common, to make these remote calls in a standardized way. The server, then, is the lightweight adapter on the other end.
The gateway for a specific tool, like Slack or PostgreSQL.
Exactly. It's single purpose. It just knows how to talk MCP on one side and how to talk to its specific system, Slack's API, the database query language, on the other. It exposes the system's capabilities via the MCP standard.
So complex logic and security in the host. Simple translation at the server edge.
That's the idea. And it's a stateful connection, meaning it lasts for a session. It kicks off with initialization and capability negotiation.
Where they basically shake hands and agree on what features each side supports.
Precisely. Ensures they're compatible for that entire interaction.
Okay, we know who guards the door, the host, and how they talk client-server. Now, what's the actual language? What instruction can the host give? MCP goes beyond just simple function calls with these three primitives.
Right, and this is where it gets interesting because it allows for different levels of control and autonomy. It's not just run this tool.
Okay, primitive number 1, tools. This sounds like the classic agent ability.
It is. Tools are actions controlled primarily by the model. They have side effects. Sending that Slack message, creating a GitHub issue, changing a file.
The LLM figures out, okay, based on the user's request, I need to use the send email tool.
Exactly. But crucially, after the host gets your explicit okay, and for the LLM to even understand what a tool does, the tool has to provide a formal description using JSON schema plus a natural language explanation. It's like the tool's instruction manual.
Got it. Primitive 2. Resources. How are these different? You said application-controlled context.
Resources are passive, read-only data. Think. The content of a file, the structure schema of a database, API documentation, they provide context.
And who decides when to fetch a resource? Not the LLM.
Typically, the host application decides. This is very common in RAG workflows, retrieval augmented generation.
Okay, let's quickly nail down RAG for everyone.
Where RAG just means grounding the LLM's response in real-time external facts. Instead of relying only on the LLM's potentially outdated internal knowledge, the host says, okay, the user asked about Q4 sales. Let me first fetch the actual Q4 sales report, that's the resource, and then ask the LLM to summarize it. It injects current context into the prompt.
Makes the answers much more accurate and relevant. Okay, that's resources. Primitive 3, prompts. You said this puts the user back in control.
Totally. Prompts are user-controlled workflows. Think predefined templates for common, maybe complex, multi-step tasks.
Like a shortcut.
Exactly. And they are always started by a direct user action, typing a / command like generate weekly report or clicking a button.
So the user explicitly says, run this specific pre-approved workflow now.
Right. This gives organizations really fine-grained control over high-value or sensitive, repetitive tasks.
I like how these primitives clearly define who's driving the model, the app, or the user. Now, there are 2 advanced features mentioned. Sampling and elicitation. They sound like they enable more collaboration.
They really do. Sampling is fascinating because it flips the usual script. Normally, the host LLM tells the server what to do. With sampling, the MCP server can actually ask the host's LLM to do something.
Hold on, why would the tool need the main brain?
Okay, imagine a specialized code analysis server. It can fetch a really complex piece of code using a resource primitive. But maybe that server doesn't have a powerful enough model itself to understand or summarize that code effectively.
Right.
So it uses sampling to ask the host's big, powerful LLM, hey, can you generate a quick documentation summary for this function I just retrieved?
So the specialized tool leverages the general intelligence of the main host LLM. That's clever.
It's an efficiency thing, and elicitation. That sounds incredibly useful.
What does that do?
Elicitation lets the server pause what it's doing and ask the user for more information via the host.
So instead of just failing.
Exactly. Imagine you tell the agent to commit some code using a git commit tool. The tool realizes, uh-oh, the user didn't specify which branch. Instead of crashing, it uses elicitation.
It sends a message back to the host.
Which then pops up a question to you. Which branch should I commit this to? It allows for much smoother, interactive, human-in-the-loop processes.
That sounds like a massive improvement over cryptic error messages. Okay, let's shift to real-world impact. MCP isn't just theoretical, it's being used now. Software development seems to be a major area.
Yeah, AI-powered IDEs are integrating this deeply. Consider a developer asking something complex, like refactor this function for efficiency and make sure it follows the patterns we use in the utils directory.
Okay, that requires understanding the current code, the project standards, maybe even past changes.
Right. So the AI using MCP would first read the current function file that's a resource via a file system server.
Hmm.
Second, read the pattern examples from the utils directory, another resource, same server. Third, maybe analyze recent commit history resource via a get server.
Gathering all the context first.
Exactly. Only then, grounded in all that context, does it generate the refactored code and use a tool primitive to write it back into the file, again via the file system server.
That seamless flow is what makes it a true co-pilot, not just a suggestion engine. What about other areas? Data analytics.
Huge potential there, especially for making data more accessible. Imagine a non-technical manager asking a chatbot, what were our top 5 products in the UK last quarter?
Something that normally requires knowing SQL or bothering an analyst.
Right. But with MCP, the AI can use a server connected to the company's database, say PostgreSQL. It translates the natural language question into the correct SQL query,
Runs the query via the server.
gets the structured data back, and then formats a clear, human-readable answer for the manager. It basically democratizes data analysis.
Before we get to the scary security stuff, one quick clarification. How does MCP relate to tools people might already know, like LangChain or Llama Index? Are they competitors?
Not really, no. They operate at different layers. MCP is the low-level protocol. It's the standardized socket and plug, the how of connecting.
The plumbing.
The plumbing, exactly. Frameworks like LangChain are higher-level orchestration layers. They are the what and when.
They provide the agent's brain logic, deciding which tool to use when, chaining actions together.
Precisely. LangChain decides what needs to happen and in what order. MCP provides the standardized way for LangChain, acting within the host, to actually talk to the tool or resource needed for each step.
So they're designed to work together. MCP makes the tool integration part much easier for frameworks like LangChain.
That's the idea. It provides that common infrastructure.
Okay. Now for the part that honestly gives me pause. Security. The sources are pretty clear that MCP's power and flexibility come with significant risks. And the main defense is the host application and the user being careful.
That's the crux of the issue, and yeah, it's a bit unsettling. The protocol itself sort of assumes the host is trustworthy and the connected servers are safe. This reliance is where the vulnerabilities creep in.
Top of the list seems to be prompt injection. We usually think of that as tricking the LLM via user input, right?
Yes, but this is a new attack vector. Imagine a compromised MCP server. It could hide malicious instructions inside the data it sends back to the host.
Hidden in. Like the content of a file it provides as a resource.
Exactly, or even sneakily embedded within the natural language description of a tool it offers. The host's LLM receives this data, thinks it's legitimate context or description.
And gets tricked into performing some harmful action.
Potentially, yes. It might be manipulated into using a perfectly legitimate trusted tool, like one that can delete files or send emails, but directing it to do something malicious based on the hidden prompt, like exfiltrating data.
Oh, wow. Okay. That's subtle. The agent thinks it's doing the right thing, but its instructions got poisoned by the data source. And then there are the supply chain risks because it's so decentralized.
Right. 2 main ones highlighted are the rug pull attack,
Where a seemingly useful and popular MCP server gains widespread adoption.
and then the developer pushes a malicious update to steal data or credentials from everyone using it.
Nasty. And the other one, slop squatting. That sounds messy.
It's kind of darkly amusing. Attackers identify tool or package names that AI models sometimes hallucinate, just make up when they can't find a real tool for a task.
Yeah.
The attacker then registers that fake, hallucinated name as a real MCP server or package. The hope is that developers, trying to fix why their agent failed by adding the missing tool the AI asked for, will unknowingly install the attacker's malware.
Okay, so given these risks, what are the concrete defenses? If the host is the main gatekeeper, what must host developers do?
They have a huge responsibility. First, implement really robust consent interfaces. Fight consent fatigue. Don't just show a generic allow tool X message.
Be specific.
Very specific. Like the CodeWriter server is asking for permission to modify the file app config.py by inserting 10 lines of code. Allow. The user needs to understand the exact consequence.
Makes sense. What else for the host?
Sandboxing is crucial, especially for any servers that might run locally on the user's machine. Strict limitations on what files they can access, what network connections they can make.
And for organizations using these agents, what's their role?
Zero trust is the mantra. Treat every third-party MCP server, even popular ones, as potentially untrusted. Establish clear internal processes for vetting and approving any new server connection. Don't let developers just add random tools.
And the server developers themselves have a part to play too, right?
Absolutely. Rigorous input sanitization is critical. They need to prevent classic command injection vulnerabilities, where a malicious user might craft input data, say, arguments for a tool that includes hidden commands like grmsrfg. Basic security hygiene, but essential.
Okay, despite the risks, the momentum here seems undeniable. Anthropic, OpenAI, Google DeepMind, all backing MCP. It really does feel like the de facto standard now. The comparison to OpenAPI or Swagger feels apt.
It really does. OpenAPI standardized how we describe REST APIs, and it transformed how we build services. MCP seems poised to do the same for AI tool interaction. The broad adoption signals the technical approach is sound.
But you mentioned one critical factor for its long-term secure success, the thing that tackles those supply chain risks.
Yes. The absolute linchpin, according to the sources, is the launch and widespread adoption of an official, trusted MCP registry.
The central directory, why is that so crucial?
Because in a decentralized ecosystem, you need a trusted authority. A vetted registry provides a way to verify the authenticity and maybe even the safety record of servers. It's the missing piece of infrastructure needed to manage trust and mitigate the supply chain impacts effectively. Without it, the security concerns remain pretty significant.
So wrapping this up, what's the big picture? MCP feels like the foundational layer, enabling the shift from LLMs as just chatbots
to truly integrated digital assistants, agents that can fluidly and hopefully safely, perform complex tasks using all the different tools and data sources you rely on.
It's the technical bridge connecting the AI brain to the digital world it needs to operate in.
Connects the brain to the hands and eyes, essentially.
So perhaps the final thought for you listening is this. If MCP really takes hold, if it becomes that universal USB-C for AI, the question shifts. It's no longer if your AI assistant can use a new tool or access a piece of data.
The question becomes, which tools and data are you allowing it to connect to? And how sure are you, really, about the code running on the other end of that connection?
That tension between incredible utility and inherent security risk, that seems like the central challenge we'll be navigating.